Hey there, in this video we're going to talk about systems of equations, we're going to talk about what they are, and how to find a solution of one. So let's go ahead and get started with the definition of a system of equation. So a system of equation is a set of two or more linear equations. So in other words, it's a set of two or more lines that use the same variables. So you'll notice in this equation I am using the variables x and y, and both equation number 1 and number 2 use those same variables. A solution of a linear system is the ordered pair that is a solution to each of those equations. Now, what does that mean? Well, these dots represent solutions on the line. Okay, so the blue dots represent the blue solutions, the orange dots represent the orange solutions. And you'll notice at this one single point that the orange dot and the blue dot overlap. Okay, so this point where these two lines overlap is a solution for the system. So for this problem, my solution is the ordered pair. Remember, ordered pairs go x and then y. Is the ordered pair, and this is the x-axis and this is the y-axis, -2, 1. So my answer, my solution is the point -2, 1. So if I'm looking at this system, I've got points along this line, I've got points along this line, and the one point where they overlap, which is right here at 1, 3, is my solution. So what do I do when I have two lines but there is no intersection? What would I say that the solution is? Well, if they are two parallel, so these are parallel lines. If I have two parallel lines, then I'm going to say, hey, they're never going to cross. Hey, my solutions on this line are not going to match any of the solutions on line 2. So I would say that there is no solution. Well, what if I look at a graph and, well, line 1 and line 2, you'll notice line 1 and line 2 are labeled here, are the same line. They're stacked on top of each other. Okay, how many solutions does that have? Well, I would say that they have a solution at every single point. Now, how do I say that in math terms? I would say that there are infinitely many solutions. Solutions. So if I'm looking at this problem, which is just like one you'll see on your homework assignment, hey, what are my answers? So for system A, where I have two lines stacked on top of each other, there's not just one solution because they don't just cross at one point. There are infinitely many solutions. For system B, they only cross at exactly one point. They only have one answer solution in common. What is my solution? Remember to list the x value first and then the y. So this ordered pair is -3, -1. And for part C, system C, these two lines are parallel, meaning they're never going to cross. So I would say that this system has no solution. Okay. So let's look at a real life example. So here's kind of when we would see systems in real life. So it says that Layla will rent a car for the day. The rental company offers two pricing options. So I'm comparing two different options and I'm trying to see which one's better. Option A and option B. For each pricing, the cost in dollar depends on the miles shown. So you can see on my graph, and let's just kind of investigate this first. If I drive 0 miles, for option A, it's going to cost me $20, and for option B, it's going to cost me $50. So option B is costing me more than option A at this point in time. Now, at 75 miles, it's going to cost me $35 versus $50. But you can see at some point, option A keeps going up, but option B stays constant. And there's this break-even point. So on this system, okay, because I've got two lines, my solution, or the point where they're going to be the same cost, would be at 150 miles, hey, for $50. So let's answer our two questions. So it says, if Layla drives 75 miles, which option costs less? So here's 75 miles. Hey, that's $35. This is $50. Hey, which option costs less? Well, option A is lower on the graph than option B, so it costs less. And we can just see by the numbers. How much less does it cost? Well, what is 50 minus 35? Well, that's 15. So it costs $15 less than option B. Okay, what's the follow-up question? For what number of miles do they cost the same? Well, we just talked about that. Okay, they're going to be the same at this single point where they cross at 150 miles. And if Layla drives more than this amount, which option costs more? All of a sudden, option A is going to be more expensive. Okay, last example. So if Laura has to choose plan A or plan B for her long distance charges, so she wants to call somewhere far, far away. So it's going to cost her more than just a normal phone plan. For each plan, cost in dollars depends on the number of minutes used per month as shown below. So plan A is this blue line. So for 0 minutes, she's not going to pay anything for plan A, but for plan B, for not using the phone at all, it's going to cost her $8. So if Laura makes a 50-minute long distance phone call a month, so she's calling her mom in Puerto Rico, hey, for example, which plan costs less? So for 50 minutes, let's find that on my graph, 50 minutes, it's going to cost $4 on plan A, and it's going to cost $10 on plan B. So which plan is cheaper? Plan A is cheaper. How much cheaper? Well, what's 10 minus 4? 10 minus 4 is, it's going to be $6 less. And then it says, for what number of long distance minutes do the plans cost the same? Well, where the intersects is the same. So for 200 minutes, it's going to cost $16 for both plans. So for what number of minutes? 200 minutes. They cost the same. And then if I plan on spending more than 200 minutes talking, so just even 225, we can see all of a sudden plan A costs more. All right, and that is what you're going to be doing on your assignment today. If you have any questions, please let me know.